Upon the next day, we covered torus barometer, right? And we solved questions related to U-tube, correct? Remember, last time we solved questions related to U-tube, right? Now we are going to continue from there. Let me teach you about a device that is used to measure pressure of gases. Earlier we learned about barometer, which is used to measure pressure of atmosphere. That's atmosphere. Now we'll talk about a device that can measure the pressure of gas. Okay, that device is called a manometer. So what's the procedure? Suppose this is a tank with gas filled in it, and let's say this is the opening from which you are supposed to take the gas out. Right? So at that opening you connect a manometer. Now what does the manometer look like? Manometer is nothing but a U-shaped tube. Manometer is nothing but a U-shaped tube that is filled with mercury. This tube is filled with mercury. So you can imagine what would happen if you don't connect anything. Then the mercury level will be same on both sides. Do you agree with me? Because on both sides there will be air. Open way, right? There is going to be air on both sides. Same pressure, 1 atm, 1 atm, so it will stay level. But if you connect it with this tank, which is filled with gas, so let's say this gas is at higher pressure, for example, more than 180. If gas cylinder में ज़्यादा pressure, you know that in a gas cylinder that you use at home, the pressure is high, correct? So let's say this is with high pressure. Suppose its pressure is PG, pressure of gas. So because if it's higher than atmospheric pressure, it will push this down. So the left arm level will go down and the right arm level will go up. Did you understand this? So now there is going to be a difference of level. Correct? What is H? H is the difference of the two levels. So now based on this diagram, we can easily find out how much is the pressure of this. Let's see. Consider one point here A, consider one point here B, same level. And let's say there is one point here C. So, do you agree first of all that PA is equal to PG? Why? Because if you have a tank filled with gas, you open this valve and connect this, gas will fill up all this space. Yes or no? You know, gas leaks through holes, correct? So here, what will be applying pressure on A? The gas. This line clear? Pressure at A is due to the gas, that is PA will be equal to pressure of gas. And do you agree that PA will be equal to PB? Yeah? Why so? Same level in the same fluid. And this is at equilibrium. We let it settle. Okay? The moment you open the valve, it will bounce up and down. After some time, it will settle. Then we do, right? Then we measure. So PA is equal to PB. But PA is PG. And what is PB? Can you write PB in form of PC? PB equal to PC plus. Who understood that? Raise your hand. It was PB is equal to PC plus rho GH. And generally in a manometer, we don't like to take water. I mean, we can use water in a manometer, it's not a problem. But typically we like to use mercury. Same reason. The density is high so that you don't have to make a giant manometer. Make sense? This big would do. Right? So, this rho is generally rho m. Rho m, that is density of mercury. What is H? H here stands for the height difference of the two arms. Okay. So finally, we can put PC's value. What's above C? In your open thing. Don't forget that. What's above C? Air. So PC should be equal to 180. Very good. So I can say that PG is equal to atmospheric pressure plus rho mgh. Did you understand this formula? Whatever is the atmospheric pressure at that, suppose you are doing this on Mount Everest, then PC's value will be different, but no problem. Right? Is it fine? So you can also write the same thing in another way. Gauge pressure. Hopefully you remember that. Gauge pressure or excess pressure is going to be PEXC, which is equal to PG minus 1 atm, that is nothing but atmospheric pressure. So you can write rho mgh. Did you understand? That is the gauge. So actually, if you think about it, we are measuring H. How do we measure H? Nothing. Take a ruler. Okay, fine. 25 mm. You understand what I am saying? You put a ruler here and see how much is the difference. Suppose 25 mm. Then you just have to put 25 mm here. So indirectly, by measuring height, we are measuring pressure. Right? I hope that makes sense. Right? See, like I said, sometimes when you are doing measurements, you have to be indirect. Like you can measure length very easily using ruler. You can measure force very easily using ruler. Sorry, not ruler, but balances. You remember those spring balance and weighing scale, bathroom scale? Yes or no? Right? The ones that we talked about in laws of motion. Right? So, like I said, some things can be measured directly, but then there are some other things that you have to measure indirectly. Temperature is one good example. When you actually put a thermometer, let's say you want to measure what temperature, you put thermometer in your mouth. Then do you realize that the mercury expands? Have you seen a thermometer or not? Yes. How many of you have seen a thermometer? Right. Okay. Have you noted that the mercury expands? It goes from less length to lot of length. And have you seen that on that thermometer there is nothing but a ruler? So there you are measuring the length, but by measuring length indirectly you are measuring temperature. Similarly, by measuring height, we are indirectly measuring pressure. Understood? Because temperature and pressure cannot be measured directly like that. Okay? So this is what we have for the gauge pressure for the gas, right? So that's the formula. Alright? Very simple. If you remember the diagram, then I'd say you don't even need to remember formula. A basics are there are some vehicles all get the concept, right? So try to decrease your burden. Don't try to rote learn, don't try to memorize everything. Doesn't help. Only memorize a few important things and everything can be done. Right? Okay, now a good thing that I want to mention here is it's important to write what are these terms. Because I see that people forget the term. Come on. What do you think is PG? Pressure over gas. Start writing one. PATM for atmospheric pressure at that point, whatever that is. Rho M for density of mercury. So suppose in exam you get a trick question where this is not mercury, but let's say they might be saying, suppose this is gallium, let's say. Right? Then obviously you have to change it accordingly. Right? H, height difference of the level, or height difference in R. So you could write H is the height difference of mercury in the R. Okay. So that's what a manometer function is. So ladies, as a variation, sometimes people use closed manometer though. Possible. If it's a closed manometer with nothing over here, then you would have to put PC equal to 0. So that's why I'm saying that don't try to memorize everything. Understand the concept, then you'll never have problems. buoyancy and buoyant force. Okay, this is a particular thing which is not directly given in the textbook, but you get questions in entrance exams, so we have to. I'm sure you all know that when you try to dip something in water, and if the density is less than water, then it will float. Correct? Okay? So, in this regard, first of all, we are going to talk about Archimedes' principle. Do you know what is Archimedes' principle? Anyone remembers it? You can raise your hand if you do. Archimedes' principle. Don't have to be exact with the words. It's okay. One or two words here and there, fine. I want to know the meaning. We just understood that there is hardly any buoyant force on the back, right? Otherwise, the back would just go off the bench, but it would not fall down, right? Like a balloon. Anyone? Come on. Archimedes' principle. Nobody would like to try? Come on, people. Come on. ખોટું હોય તો કઈ વાંધો નહીં. હું તમને તમારા 9th ના સરનું નામે નહીં પૂછું. ખોટું પડે તો. Would anyone like to try? Okay, fine. I don't understand why are you all so hesitant. So what is Archimedes' principle? It is that the buoyant force acting on a submerged or immersed solid is equal to the weight of the liquid or the fluid, whatever you write, displaced by it. Okay. Is anyone going to ask you this sentence? No. એવું બધું 9th માં પૂછે. હવે કોઈ ન. Okay, but you need to learn how to use this. So first of all, we are going to convert this sentence into a short format. Right? So Archimedes' principle is saying that the buoyant force, Fb, buoyant force, okay, is equal to weight of the liquid or the fluid displaced by that body, whatever body or whatever solid is immersed. Solid is a body, right? Okay. So Fb is equal to weight of W of displaced liquid, right? Fb is equal to W. W, that is work, weight of displaced liquid. So you could write it like this: mass of displaced liquid into G. How do you find weight of anything? Mg, right? But how do you find mass of a fluid or liquid? You can always write density of the liquid or the fluid into volume displaced into G. Is this clear? Yes? No? Sure. Okay. Another way to write, if you don't like this displaced thing, okay. You don't like the word displaced. What if we change this to here is as follows: Fb is equal to rho L V inverse. Do you understand the meaning of the word inverse? Inverse, that is how much is inside. That is called inverse. That part is called inverse, isn't it? Sure, you understand that completely? Right? So Fb is equal to rho L V inverse into, again, V inverse stands for only the part that is inside fluid, not total. V inverse stands for the part that is inside fluid, not the total. Okay. So that is the formula of buoyant force, and it is given by Archimedes' principle. Alright, we're going to prove it. આર્કિમિડીઝે કહી તો દીધું પણ એમ કઈ ન માની લેવાનું. આઇન્સ્ટાઇન કહે તો એક પ્રૂફ લાવો, પ્રૂફ. That is what science is. It demands proof from everyone and it knows no authority. Newton 50 વસ્તુ કહી દે તો કઈ વાંધો નહીં. What is wrong is wrong. Okay? So we need proof for things. So I'll try to follow that spirit. Whenever possible, whenever within the bounds of your mathematical knowledge, I will try to give you proofs. Okay? Right. I'm going to erase this. Again, this is an important formula. अच्छा नहीं नीचे पहला terms लग लो, proof तो बची लग. Okay, so what is FB? Buoyant force. अच्छा एक से ना direct लग. Upward. Okay. Buoyant force is in upward direction. FB for buoyant force. Rho L for density of liquid or fluid. You can write or fluid. For simplicity, I have written liquid. Okay. It is equally applicable for gases, mind you. Right? It is equally applicable for gases. Then VIMM or V displaced. They look like. Okay, you have choice. Choose whatever suits you. V inverse or V displaced. What does that mean? Volume that is inside the fluid or liquid. Clear? Volume of the body or volume of solid inside the fluid or liquid. And you very well know what it is. I am not going to bother about that. Again, V inverse stands for volume of solid inside the liquid or fluid. Okay, so that's what we have. I'm going to erase it now. We'll prove it. Do you remember that cylinder, imaginary cylinder that we had drawn earlier when we wanted to derive that PV is equal to PA plus rho J? More or less the same derivation. So let's say that this is a vessel which is with water or some fluid, and I'm going to take off a case. I'm going to derive this for a simple case where this cylinder is now a real cylinder. Okay, it's a real cylinder. Again, you could do it with a cuboid, no problem. We are taking cylinder for simplicity. Right? It works for any shape. So let's say this is a real cylinder now, which is suppose made of wood. Suppose this is a real cylinder made of wood. Cross-sectional area A. I hope you remember now what that means. And length, let's say h or height. So we'll find out how much is the buoyant force acting on it. We'll prove it. Okay. So first of all, you should understand what is buoyant force. Buoyant force means the upward force, the net upward force acting on this solid. I repeat, buoyant force means the net upward force. Net means what? Total. Acting on this solid. Sorry, I missed out. That means net upward force. Change it like this. Applied on this solid by the liquid. Okay, that makes it perfect. Net upward force applied on this solid by the liquid or the fluid. So that is it. So let's draw FBD. Here I am going to draw FBD. I have some space. You can draw whatever you want. Mg, clear or not clear? Whose mass is this? Mass of this solid. Okay, I am just writing M. Okay, and there are going to be two forces. One from pressure above. Let's say this upper point is A. So this is going to be PAA. And let's say the point here is B. So then that's going to be. Actually, that's bad. XY. tell you why. We have taken A for area and we have taken B for buoyant. So when B comes up with again, so confusion doesn't happen. I don't want X, and upward will be P Y E. So three forces are active. But just writing this sentence, we can clearly understand that FB should be equal to PYA minus PXA. Yes or no? Try to understand what this sentence is telling you and look at this FB. I hope you can still read this properly. This is MG and this is PYA. Read the sentence. Raise your hand if you understood this line. Okay. Sure? It says net upward force applied on this solid by the liquid. Out of these three forces, which are applied by liquid? PXA and PY. Clear? MG is not applied by liquid. Leave them. So now you have to find net upward force. Net upward means you have to do addition. But this is in opposite direction. Clear? So net force due to liquid or by the liquid is PYA minus PXA. Take a common. Okay, what's left behind? PY minus PX. What is PY minus PX? Use the formula that we have derived earlier. It will be rho LGX. Is it? Yes or no? Rho L, that is density of liquid. Clear? The formula is PB equal to PM plus rho G. But here we have PY and PX. So we are going to write rho L G H by the subtract. Variation of pressure with depth. Okay, now what is H into A for this cylinder? Volume. So do you see that this whole volume is actually immersed inside? And that's why we are getting the whole volume. Suppose in another case, this cylinder was, let's say, only partly filled. So B point here leva pade. Do you agree? X and Y. You can't take it here. I hope you realize why. Is there any liquid here? So we have to take 2 points here. X and makes sense. Then if you do it similarly, if you are going to do it similarly, then here you not get H. Instead of that, you get FB is equal to rho LGH by 2 into A. Suppose this that happened. Understood? Again, in both the cases, we are getting that this volume is the volume that is inside the fluid. This half volume is, you see half the volume, AH by 2 is inside. So every time like this, you are going to get the same. What's that? The formula will always be what we wrote earlier. FB equals rho L into G into V inverse into G. Clear? Please remember this. Alright? So this is the buoyant force and it is in which direction? Upwards. Right? Write it. Okay, give it a minute. Again, remember that this derivation is independent of the shape. We took cylinder for simple calculation. You could have done it for any random shape. You can do it for a sphere also, right? Or irregular. But we are trying to keep mass to a minimum. Okay, I'm going to do it. Okay, so this is what buoyancy and buoyant force is. Let's solve a question. Suppose there is a block of density, let's say 800 kg per meter cube. It would be something like wood or plastic. The block of density 800 kg per meter cube floats on water surface. How much of its volume is above water? You have to give the answer in percentage. Right? You have to give the answer in percentage. Okay, so that is how much percentage of its volume is above the surface, above water. Okay. Draw a diagram first. Let's say this is the vessel filled with water, and here is that block. Again, shape is not important. You would have noted this, right? When things float on water surface, a part is outside water and the rest is inside. Have you noted that ever? Right? So that's what this question is about. How much will be above water and how much will be below? But you can find both of them together. So we are going to draw the FPD of this one. Right? We are given density of this solid. Okay, so you can write rho S. S for solid, 800 kg per meter cube. Okay. We know density of water is 1000 kg per meter cube. Now we are going to use the buoyant force. Okay. Again, it's about forces. And if you want to get a good grip of or good grip on forces, you should draw FPD. Draw FPD of this block. Tell me how many forces will act on it. Draw FPD of this block. How many forces will act on this block? Meanwhile, I'll write down one more question. Done. What's the answer? No, सन्नाटा क्यों है भाई? What did you do? Did you draw FPD? How many forces? आज जेने नहीं आवड़े कि बार बेच जाए. Raise your hand. How many forces? No hands up immediately out. बराबर? How many forces on this block? जो हाथ ऊंचो નથી થતો પછી કમ્પ્લેન નહીં ચાલે. પ્રોગ્રેસ બુક ને એવું કઈ આપ્યું કે નહીં તમને? તો કઈ નહીં, પનિશમેન્ટ મળી જશે સીધી. How many forces on this block? So first of all, I am going to simply make those people's hand who are not raising their hand. You are raising your hand? No. Why not? What's your name? Stand up. What's your name? Param. Karan. બધા કરણ તો આવા નથી હોતા. મેં તો કરણ અત્યાર સુધી બધા એકદમ ઓબીડિયન્ટ હોય. ચલો કઈ વાંધો નહીં. Why did you not raise your hand? You don't know. Were you attending online classes? Yes, you were. Okay. Now, since everyone has raised hand, I can practically ask anyone and you can't deny. Put your hands up. Okay, you see my trick? Right? Nisha. How many forces? Louder. Nisha, Nisha. Sit down. How many forces? 3 forces. Which 3? Can't hear you. એને નથી સંભળાતો. અહીંયા મને સંભળાય. Say it louder. Shout.
First
FA. Okay. So if I'm drawing the FA here, FA from where? Arrow downwards. What arrow upward? Yeah. So you are saying that this force here on A is downwards. Okay, fine. Then MG. In which direction? Downward direction. Okay. Then FB. FB, that is buoyant force. Okay. One more force by fluid. So I don't want to call it FB. Let's just write F1 and F2. Anything else? Sure about that? It's right. Sit down. But we can simplify this further. I'll tell you what. Like I did it when I was deriving that Archimedes principle. F1 and F2 can be combined together. Listen to this carefully. F1 and F2 can be combined together. And we can just write one buoyant force. That is in which direction? Upward. You can draw either there or here, doesn't matter. Alright? What is FP again? FP is the total of those F1 and F2 we have drawn earlier. Make sense? Right? So you can just draw one. It's good enough. Clear? So only 2 forces. Which 2 forces? Mg and buoyant force. Why is there a buoyant force? Because this is immersed in liquid. Do you still have that list? Maybe at home you'll have that list of questions for FPD, isn't it? It's time to add one question to that list, isn't it? What's that? Is it immersed in a liquid or fluid? If yes, then there will be which force? Buoyant force. In which direction? Upward direction. Karan, I'd like to know why you couldn't answer this question. Did you not understand? You have to say something. You didn't understand. Then why didn't you ask a question if you didn't understand? Have you attended all the online classes so far? Sit down. Well, so this is FP and MG. Right? Well, so when it settles, it's going to be in equilibrium. So we have FB is equal to mg. When it settles, it will be in equilibrium. So now we have to find out how much volume is outside water. So first of all, we'll use FB formula. What is the FB formula? What's the formula of FB? Rho L V immerse into G is equal to mg. M is mass of the block. Is mass of block given? Is mass of block given? Given? What is the mass of block? 800 is mass of block. 800 is the density. So whenever you want to find mass and you don't know it but you know density, you can always do it as density into volume. So this is density of solid into volume. Whose volume? This volume is whose volume? So only this part? Only this part? Which part? Whole part or only the one above? The whole part, right? So because we want to find mass of block, so you should be writing volume of block. And volume of block is the whole. So here this is V, you could just write V block if you want, or I just write V. Understood that V is volume of block into G. So let's simplify things. G is cancelled. We want to find percentage that is outside. The plan is as follows. We will find percentage inside. We will find percentage inside and the rest is outside. Easy to understand? So to find percentage inside, what should we multiply by 100? Can you tell me, to find the percentage inside, what should we multiply by 100? You understood what I am asking? We want to find how much percentage is inside. Then what should we multiply by 100 to get that percentage? Raise your hand. Okay. આવી રીતે બધાને આવડે છે. એકલા એકલા બહુ ઓછા લોકો કરે. Raise your hand. હમણાં તો એટલા બધા બોલતા. ક્યાં વયા ગયા બધા? Okay. People are still there, right? Be confident. મેં તમને કેવું કહી દીધું. ખોટું પડે તો કેટલી વાર ખોટું પડે. હજી તમને એક વીક નથી થયું સ્કૂલમાં આવ્યા. Physics has not shown its true colors. Right? વિચાર કરો, આમાં આટલી તકલીફ પડે છે. આની પહેલા ચેપ્ટરમાં કેવું મસ્ત બોલ્યું દીધું ઓનલાઈનમાં. ફ્લુઇડ મિકેનિક્સ અને તો અહીંયા આવ્યા તો ઘણી બધી તકલીફ પડવા પડી. કેવી રીતે લોઝ ઓફ મોશનમાં અહીંયા આવ્યા તો હું તો તમને રોડ આવી નાખે. બરાબર ને? તમે એમ જ કે અમારે કોમર્સમાં જ જવું છે, નો સાયન્સ. Okay. Priya, what's your answer?
V immersed.
Stand up.
V immersed into 100.
અહીંયા હું લખું V immersed into 100. That will give me percentage of volume immersed. Sure? Who agrees with me? Who disagrees? Who says the answer should be something else? It's not this, something else. Okay. Yes, Raj?
V immersed divided by total volume into 100.
V immersed divided by total volume, that is V into 100. What is your answer? Same. Yours, Salam? Same. Three guys are saying it's same. That's right. Sit down, please. Well tried though. V immersed upon total into 100, right? How do you find your percentage? Is your mass divided by total into 100, isn't it? Same thing. V immersed upon total volume into 100. Clear? So, do you see, I can easily find this from here. What will be this equal to? Tell me the value. What will be V immersed upon V equal to? It will be rho S upon rho L. Correct? Yes or no?
Yes.
Rho S upon rho L. How much is rho S upon rho L? 0.8. Very good. Okay, 800 upon 1000, 0.8. So this, how much percentage is inside? How much percentage is inside? 80% is inside. So what will be our final answer? What will be our final answer? 90%. 92%. 92%. તમે લોકો કઈ ખતરનાક કેટલો પછી લાસ્ટ સ્ટેપમાં કેલ્ક્યુલેટર ની જરૂર ન પડે. કોણ છે? વોટ્સ યોર નેમ? સોરી, Suchit. Okay, Suchit. Really, trust me, it doesn't need a calculator. It's that simple. Okay. First of all, you find percentage inside. How much percentage is inside? Tell me. How much percentage is inside? 80, correct? अरे तो बाकी कितना क्या percentage? वो बड़ी वो बोलता था. थोड़ी बार तो मैंने ऐसे क्योंकि आडस्टर एक अच्छे. આગળ સમજી ગયા ને? સમજી ગયા ને કે ન સમજી ગયા? પછી મને એવું નથી કરવું, હજી નવા આવ્યા છે. ઓકે. So percentage inside 80, percentage outside 20. Fine. આ વેલ્યુઝ બધી નાખે તો સોલ્વ કરતા આવડે આવડું જ જોઈએ નહીંતર કોઈ બરાબર ને this question is waiting for us યાર નો લખીને રાખજો Is this solution? Yes. Question फटाफट लग दो. And see, I said something. If you really care about JW, then please stop caring about your handwriting. જવાબ દેવાનું લખી નાખવાનું ગમે તે handwriting માં ફૂલ સ્પીડ માં લખો અને રફ વર્ક કઈ કરતા શીખી જાઓ આડું આડું એવું લખવાનું કે કોઈને વંચાય નહીં સિક્રેટ ઓકે because in JW you have to do a lot of rough work તમે બધા આન્સર આમ વ્યવસ્થિત લખવા બેસો JW માં તો તમારે 3 કલાકમાં 10 સમય નહીં થાય ખાલી ફિઝિક્સ ના નથી કરતો ટોટલ you have to solve 75 okay so please stop caring about your handwriting worry about that after 12th standard right now you let it go જોને મારા હેન્ડરાઇટિંગ કેવા છે ડીમ સિટી લઈ ગયો actually teaching has improved my handwriting once I think in March or April I found my old graph book which was from 9th standard I couldn't recognize that I have written it was horrible okay So here is the question. Did you understand the meaning? I only joke देवो question मतलब. If you understand what the question is asking, it says that we are taking 1 kg metal and we are taking 1 kg of wood. Isn't it? And now what are we asking? What is the difference in their weight? Same अच्छे weight क्या अलग है? सेम के अलग છે સેમ હોય તો આન્સર 0 અને કદાચ માર્ક્સ છે માર્ક્સ કહું છું માર્ક્સ નહીં માર્ક્સ બરાબર ને માર્ક્સ છે 0 because 0 is the wrong answer okay we want to measure their weight means how do we measure weight using spring balance याद करो procedure what does spring balance really measure does it measure weight what does it measure one going normal force that's slightly incorrect spring balance bolu remember that the one with the spring so it measures tension who said that very good yaad aayu laws of motion spring balance measures tension and the one on which you have to stand which is called weight scale or bathroom scale that measures normal these are questions like that do you remember okay so here basically we don't have to find difference in weight we actually have to find difference in tension the way diagrams draw karo basic situation one for metal one for wood and draw FPD and find out tension for metal tension for wood find the difference that's your answer Please wait fast. FPD done. Woolly block જેવો draw કરવાનો. ચાલ કોઈ જોવા નહીં આવે. Downward force mg. Upward force tension. Is that it? Is there anything else? Read the whole question. Like the information આપી દે. તો કામ આપી હશે. Air is a solid liquid or what? Air is a gas. Gases are fluids. Whenever something is inside a fluid, there is always a buoyant force. So only for buoyant force. You understand what I'm saying? Air is a fluid, and fluids can apply buoyant force. So there will be a buoyant force on this metal, let's say, first case metal. Right? How much buoyant force? That we will find out. FB. In first case, FB1. Understood why I have written FB1? Who is applying buoyant force on this metal? Who is applying buoyant force on the metal? Answer. Air. That's a concept of air is a fluid, and fluids apply buoyant force. Okay. So now, in equilibrium, when you hang something, it should stay in equilibrium. No measure. Right? So if it is in equilibrium, can you find what is P1 equal to based on this? Get the expression first. The expression. Very much important. Get the expression. Yes?
mg minus fp1.
mg minus fp1. Very good. Who agrees with him? You get this? Thank you. Okay, very good. Sit down. Yeah. Again, we get it from T1 plus FB1 is equal to mg. I hope that's clear. So on that side. Similarly, second case. कहीं draw करવું નથી આપણે હવે સમજી ગયા ને બરાબર એનો સમજી ગયા is mass same for both? Is mass same? First case for metal, second case for wood. Is mass same? Yes, no. Yes or no? Yes. How much mass? 1 kg. Both are of 1 kg. 1 kg is mass. So you put them equal. They are equal. Now, if I want to find difference of weight, I should do what with these two equations? Clear? Let's subtract. So what should I write? Let me show you the method. Okay, I'll leave the calculation for you. Let me show you the method. T1 minus T2. MD will get answer. And when you do T1 minus T2, you get FB2 minus FB1. Understood? Because two negatives will make this positive. So FB2 minus FB1. Okay, what to do now? Put FB's formula. What's FB's formula? Use that formula. Rho L. L means liquid or fluid. Which fluid here? Air. So density of air into volume immersed. So let's say I'm measuring 1 kg metal block here. Then how much is immersed in air? Full. Right? So basically, I should be writing in both the cases. I should just be writing volume of that whole thing. So in second one, I should be writing volume of wool into G. Correct? Understood this? Then I should put a minus sign. Density of air. What should I write for first case? Which is of metal. What should I write? Volume of metal. Okay. Into G. What's common? G is common. Rho A is also common. Okay. Now VW minus VL. Read the whole question. Is volume given anywhere? No. Mass given? Density is given? Can you get volume? Yes. Now I leave it. Okay. From here on, I am leaving it to you. You have to find what is VW, what is V. In fact, if you don't put values, it will become easier. Check this. Do you understand this or not? I will not explain. I'll just write it. Try to understand it on your own. Okay. The rest is for you to finish. You can use a calculator, no worries. Alright? Because the numbers are not going to be that bad.